Greetings. Welcome to Machines vs Mathematics channel. In our last lecture, we have shown square root of 2, the irrational number, that is 1.4142135624 so on, accurately on a real number line. Yeah. So life is really simple, showing 1.5 or 0.5 or negative half or 1.8 or 2.3, some minus 2.5, something like that on a real number line. Yeah, the actual the actual stuff will come out when you are able to show these irrational numbers that accurately on the same real number line. So here we'll try to investigate now how to show this irrational number. Okay, so in our last lecture, what we have done is, yeah, so this is our last lecture's page C. So square root of 2 is this. Now we have shown this accurately on the same number line. So we took a number line on which we have positive integers and negative integers and 0. 0 is neither positive integer nor negative integer. And we have shown at this point P we have this number, this real number. So we took help from Mr. Square. Yeah. So Mr. Square helped us in accomplishing this task. Okay, so we took a square of side 1 unit each, and we had vertices like this. So A, B, C, D, we have 4 vertices, and now we transferred this figure onto this number line so that the vertex A will coincide this 0 on the number line, and as follows like this. Now we have joined a line from A to C. Now this line will act as diagonal of the square ABCD. Now in this case, the same diagonal will also act as a hypotenuse. Now so therefore this AD will act as adjacent and DC will behave as an opposite side. So now we applied Pythagoras rule or Pythagoras theorem. See, the only theorem with more than 300 proofs, yeah, is Pythagoras theorem. Imagine a theorem with more than 300 proofs, 300 ways you can prove the same theorem. So if you have time and if you're lovers of mathematics, you just try to unlock at least some 3 to 4 of that Pythagoras theorem, because you can gain lots of insight in that Pythagoras theorem. So devote your quality time investigating or unlocking these mysterious concepts. Okay, so anyways, let's come back to this lecture. So we took this triangle here, I mean a right angle triangle. So here we have it's a right angle triangle. So now this is hypotenuse, so AC is equal to, we have this, anyways we have sides as 1 units, we have 1 unit on each side, so therefore we got AC is equal to square root of 2. Okay, once we obtained AC is equal to square root of 2, now we took a compass. Yeah, this is your compass, adjust your compass like this. So you fix this compass at point A. Now AC as a radius, we drew an arc, and now this, see, with AC as a radius we drew an arc like this, and this arc is intersecting at this point P. Now this point P is nothing but this beautiful number 1.414213 so on like that. See, our attempt in finding out this real number on this real number line is successful. Now we have to venture in finding out this square root of 3. Okay, so we have to show this square root of 3 accurately on the same number line. Let's redraw the number line. let's redraw. So successfully I managed drawing a straight line somehow. So let me take again 0. 0 is neither positive integer nor negative integer, so let's take 1 and say 2, 3, so on and so on. Oh my, yeah, sorry. Okay, so on. This fellow is going until he reach infinity, and towards left hand side my journey, towards left hand side my journey is going towards a negative infinity. Okay, the same square, where is my blue color? Where you kept my blue color? Sorry. So the same square, we will draw it here. Okay. So now side is, of course, you have a square of side 1 unit. Now we have also vertices. We took vertices as A, B, C, D, and now we had a diagonal like this. Okay, so now this is a right angle triangle, that is ACD. So this ACD is a right angle triangle now. Okay, and now if it is 1 unit, now this fellow is square root of 2. This diagonal length is square root of 2. Now any idea how do we locate square root of root 3 accurately on this number line? Any idea, please? See, sometimes we have to go beyond this box. Okay, say you have a line AC and extending, you really not required to extend the line, but for simplicity point of view I extended the line on both ends at A and C. Okay, so now what we have to do, you have to construct, say, let's try to construct. Okay, so we have CE. Okay, we have CE. So we have constructed now CE of unit length. So length is 1 of unit length. Now this CE is perpendicular to AC, right? So this CE is perpendicular to AC. So AC is this. Now CE is this. So CE is exactly normal to this AC or perpendicular to this AC. Now meanwhile, we know that AC length is square root of 2, and now CE is of length 1. So now what to do? Now we can construct one hypotenuse. We can construct a hypotenuse like this. Okay, so we have constructed now an hypotenuse AE like this. Now what is the length of this hypotenuse? Yeah, now this is your right angle triangle. Yeah, this AC will become now adjacent or base, and CE is opposite side. Now AE is hypotenuse. This AE is hypotenuse here. All right, so therefore this AE. Now what is AE? So we know that according to Pythagoreans theorem, hypotenuse square is say adjacent square plus opposite square. Okay, so therefore AE is, again these two fellows are sitting inside a square root now. Okay, so AC is of what length? So this AC is square root of 2, so square root of 2 whole square, and the CE is of length 1. See, AC is equal to square root of 2 and the CE is 1. So 1 whole square. Okay. So again these two are sitting inside a square root and this is what our AE. Okay. Now what is this? This is square root of 3. So AE successfully we have obtained AE as square root of 3. Now again what you do? You take your same compass. Okay, again shall we draw this compass? I'll try to manage somehow. Adjust. Please adjust. Okay. So say here is your pencil and say this is your needle, say your pencil is this. Okay. You take your compass. Okay. You fix this point at this A again. At this A. Now center at A and radius as AE. You take radius as AE. Now this AE is what? This AE is square root of 3 because we found A is equal to square root of 3, right? So this square root of 3. Now draw an arc. Center at A, radius as AE. You draw an arc like this. You draw an arc. Now this arc is going all the way down. Now it is this arc intersected here, you see this point. Now say this point is some Q. Okay. Now this point, you know what this point is? This point is 1.7320508076 so on. Okay, that's it. See how simply we have shown this this real number, this big real number on this real number line. Okay. Now please devote your quality time. And how do you find square root of 4? It's simple. 2 you can show very happily. But what about square root of 5? Square root of 6? Square root of 7 so on? How do you do that? Now use this figure. Okay. Use this figure. This figure will act as a base for finding square root of 5, square root of 6. I mean how to represent them or how to locate them on real number line. Okay. Thank you very much.